In this video on section 11.5, you will learn how to find the probability with counting methods such as permutations and combinations. The objective here is to compute probabilities with permutations and combinations. In example 1, Kim, Ian, Larry, Sergio, Katrina, Dawn, Maria, and Eduardo have all been invited to a dinner party. They arrive randomly, and each person arrives at a different time. In part A, how many ways can they arrive? We can use the fundamental counting principle to find the total number of possible permutations by setting up a task for each person who arrives at the dinner party. Since there are 8 people, I'm going to draw 8 spaces to represent each of the tasks of a person arriving. Since there is a total of 8 people, there are 8 choices for the first person to arrive. So we put 8 here, 7 possible choices for the second person to arrive, then 6 possible choices for the third person to arrive, and so on until we are left with just 1 person left for the 8th person to arrive. When we multiply the numbers together, you can write it as 8 factorial on your calculator, and 8 factorial is equal to 40,320 different possible permutations of guests arriving at the dinner party. And just as a note, we do know this is a permutation because the order in which they arrive actually matters. Now, we're not doing probability just yet. We're just finding how many ways they can arrive. In part B, how many ways can Kim arrive first and Eduardo last? Since there's only 1 choice for Kim to arrive, we put her first and Eduardo is last. So we only have 1 to choose from in each of those positions. Once those 2 people are taking up, then we have 6 people left to arrive second, 5 people left to arrive third, and so on until there are just 1 person left to arrive 7th. Multiply this together, and we have 6 times 5 times 4 times 3 times 2, which is 720 different possible permutations of guests arriving at the dinner party for when Kim is first and Eduardo is last. The part C is now to find the probability that Kim will arrive first and Eduardo last. So we've done all the work here in part A and B. So in probability, if you recall, the formula is the number of favorable outcomes in our event divided by the total number of possible outcomes in the sample space. The event is that Kim arrives first, Eduardo last, and we've already calculated there are 720 different ways that can happen. So the probability that Kim can arrive first and Eduardo last is 720 divided by the total outcome, which we said was 40,320. And that reduces to 1/56, and that's equal to 0.0179. I'm going to go ahead and open up my calculator just to work out the problems with you. Make sure that you are using the math using your calculator. We're going to type the numerator, which is 720, divided by the denominator, which is 40,320. And before I hit enter, I'm going to hit math. And I want this as a reduced fraction. We hit enter twice, and that's equal to 1/56. If we want to write that as a decimal, go to math, 2, enter, and you get a decimal equivalent to 0.0179. So the probability that Kim will arrive first and Eduardo last is 1/56 or 0.0179. In example 2, 6 stand-up comics, A, B, C, D, E, and F, are to perform on a single evening at a comedy club. The order of the performance is determined randomly. Find the probability that comic D will perform fourth. So first we need to find the total number of possible permutations that all 6 comics can perform. Since there are a total of 6 comics, we have 6 possible choices for the first person to perform. Then we have 5 left who can go second, 4 left who can go third, and so on until we have 1 person left who can perform sixth. And the total number of ways that can happen is 6 times 5 times 4 times 3 times 2 times 1, or 6 factorial, which we can do together. 6 math probability, and go down to number 4, hit enter, and that's equal to 720. Now remember, to find the probability that comic D will perform fourth, we now have to find out how many favorable outcomes where D is fourth. So we go down here and we write down our tasks where all 6 people are to perform in a given night. Since comic D is going fourth, we put 1 person there. Then we fill in with the rest of the comics. We have 5 left who can go first, 4 left who can go second, 3 left who can go third. Then skip over here to the 5th person. There's 2 left who can go there, and finally 1 person remaining who can go last. So the number of ways that comic D can perform fourth is 5 times 4 times 3 times 1 times 2 times 1, and that's equal to 120. The probability that comic D performs fourth is this number 120 divided by the number in our sample space, which we did first, and that's 720. So 120 divided by 720, math, enter, enter, that's equivalent to 1/6. Math, to enter, and that's equal to 0.167. In part B, we're looking for probability that B will perform last and F will perform fifth. Now we already found out the sample space, the total number of outcomes for all 6 comics to perform is 6 factorial, or 720. So here we need only calculate how many ways comic B can perform last and F performs fifth. We write down each of our tasks and we put 1 person who can go fifth, 1 person who can go sixth, and since we have 6 comics, there are 4 left we could choose from to go first, 3 left to go second, 2 left to go third, and finally 1 person left to go fourth. And there are 4 times 3 times 2 different ways that this can happen, and that's equal to 120. So the probability that comic B can perform last and F to perform fifth is the number of outcomes in our favorable event divided by the total number of outcomes in our sample space, which is equal to 120 divided by, what was that number up here? 720. I don't think I didn't put that right here. Let's put that down. 120 divided by 720. Actually, that's not 120. That is 24, isn't it? 24. So the number of ways this can happen is 4 times 3 times 2 times 1, which is 24. And the probability that comic B performs last and comic F performs fifth is 24 divided by 720. And let's put this on our calculator. 24 divided by 720. Math, enter, enter, is equal to 1/30. And let's get this as a decimal. And that's equal to 0.033. Part C, find the probability that the comedians will perform in the specific order EACFDB. Since there's only one way that can happen, the probability is 1 divided by 720, which we already calculated the first part of this problem, and 1/720 is equivalent to 0.001. In example 3, a box contains 15 transistors, 4 of which are defective. If 4 are selected at random, find the probability that all are defective. So let's first determine the total number of ways to select 4 transistors from a box of 15. And because order is not important here, we will use the combination formula. We calculate the combination of 15 items taken 4 at a time. That stands for the 15 transistors chosen 4, right? 4 are selected at random. So N is 15, R is 4. We can put this in our calculator, or we can do this by hand by using the formula for combination. N, the combination of N items taken R at a time is equal to N factorial divided by N minus R factorial times R factorial. Putting this on our calculator, I'm going to math, probability, NCR, which is number 3. N is 15, R is 4. Hit enter and we get 1,365 ways to select 15 items 4 at a time. Next, we calculate the number of ways to select 4 transistors that are all defective. Because there are 4 defective transistors and we are selecting 4, that means N is 4 and R is 4. So we have the combination of 4 items taken 4 at a time. All right, so this is the numerator part of our probability. All right, how many different ways can we select 4 transistors that are all defective? So this is the combination of 4 items taken 4 at a time. So there's only one way to choose all 4 that are defective. And we're going to find the probability. We're going to take 1 and divide it by 1365. So the probability that all 4 are defective is 1/1365. In part B, find the probability that none are defective. Now we already found the denominator in part A. We found that the total number of possible outcomes to choose 15 transistors 4 at a time is 1365. So what we're looking to do is find the numerator, that none are defective. If there are 4 defective transistors in a box of 15, then we know that 11 are not defective. We found that just by subtracting 15 minus 4, okay? So now that's our new N. 11 are not defective. And out of those 11 that are not defective, we're choosing 4. So this is the combination of 11 non-defective transistors taken 4 at a time. We go to our calculator, 11 transistors, and we're taking this 4 at a time. Hit enter and we get 330. To find the probability of selecting 4 transistors such that none are defective is 330 divided by 1365, which reduces to 22/91. Now we're going to go to some problems where we find the probability using a deck of cards. This is a standard deck of cards without the jokers. We have 52 cards total. 26 cards are black, 26 cards are red. We have 4 suits: clubs, hearts, spades, and diamonds. And in each suit, we have 13 cards: ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. In each suit, we have 3 picture cards or face cards. And those face cards are jack, queen, and king. We have a total of 12 face cards or picture cards in a deck. Now we're going to go to example 4. A hand consists of 5 cards from a well-shuffled deck of 52 cards. Find the total number of possible 5-card poker hands. So we're just finding the number here. Since the order in which we have this 5-card hand does not matter, this is a combination of 52 cards taken 5 at a time. So we go to our calculator, 52, math, prob, NCR, which is number 3. Then we put in the number 5, hit enter. So the total number of ways to have a 5-card poker hand is 2,598,960. Part B. A club flush is a 5-card hand consisting of all club cards. Find the number of possible club flushes. Now in this problem, we are only looking at the club cards. So our total number of club cards is, if you go up here to our diagram, I'll find it in just a minute. There it is. 1, 2, 3, 4, 5. All right, so we have 13 clubs here at the top. So that is my new N. Find the total number, or find the number of possible club flushes. So we're taking 13 cards 5 at a time. This is the combination of 13 items taken 5 at a time. We'll put this on the calculator. And that number is 1,287. Now we're going to find the probability of being dealt a club flush. That means a 5-card hand with all clubs. And then round this to 6 decimal places. Okay. Now this is going to be highly unusual to just be dealt a hand in which all of the cards are clubs. But we've already done the work here. The probability is the number of outcomes in our event divided by the number of total outcomes in our sample space. The number of outcomes of getting a 5-card consisting of all clubs is 1287, and we're going to divide that by this 2 million number and put this on the calculator. And it said round to 6 decimal places. So I'm going to go ahead and do this with you. 1287 divided by 2,598,960. Hit enter. And we have this number that's rather strange on our calculator, 4.9519 ... all the way down, and then it says e to the -4. This is standard deviation for 10 to the -4. Let's work this out together. divide 1287 over 2,598,960. Hit enter, and we get this number 4.95 times 10 to the negative 4, which represents the decimal 0.0000495. Just remember that this is scientific notation if you get this e to a negative number or e to a positive number, okay? This negative number means that you move the decimal to the left 4 places. If it was positive, you would move it to the right. So that's what we did here. We moved the decimal from right between the 4 and the 9 to the left, 4 different places to the left. We get 0.00495. In example 5, if you are dealt 3 cards from a well-shuffled deck of 52 cards, find the probability that all 3 cards are picture cards, and then round to the 6 decimal places. First, we're going to find the total number of ways to be dealt 3 cards from a deck of 52. So that is the combination of 52 cards taken 3 at a time. So we have 22,100 ways of getting a three cards from a deck of 52. Now the next thing we're going to do is find the probability, or find the number of ways that 3 cards are picture cards. So we need to know how many cards are picture cards. Going up to our deck here, we see that there are 3 cards in each suit, and 3 times 4 is 12. So there are a total of 12 picture cards in a deck. So the number of ways to receive all 3 picture cards is a combination of 12 picture cards taken 3 at a time. And notice that the R, this is the combination of n items taken R at a time. Notice that R is the same in both of these setups, to get the total number of possible outcomes and also to get the total number of outcomes in our event. So the combination of 12 items taken 3 at a time is equal to 220. The probability of getting all 3 that are picture cards are 220 divided by 22,100. And the decimal is 0.009955, rounded to 6 decimal places here. And that's the end of my handout. Have a good day. And the next lesson, we're going over 11.6, probability with OR.